Yeah, so our question here, 73, is asking us about this graph, g of x, right there, and you drew it already. So the first thing that's asking us is g of x a function? And how could I possibly tell if it is or not?
So we know functions, kind of what defines our function is that for every input, we can only have one output, or in other words, that for whatever x I get, I need a consistent y value. So
Hmm.
the way that I thought about this is, any input that I take, any x value that I take, it's only going to hit that graph one time, or you're only going to get one y value back. So I gave that example of when we plug in 0, thinking about the soda machine, when I hit 0 for my input, I'm always going to get back 3. I'm never going to get anything different. So it's always working consistently. So it is going to be a function then.
So what would it look like then if like your so a function machine or soda machine wasn't like if I pushed 0 and then got like 3 one time and then I push 0 again and then I get out, I don't know, -7 or something.
Yes. So if we had, maybe there was two lines, or maybe this ends up curving back down and goes something like this, and then stops over here. Well, this would be that case where we would get g of 0, which would work up top, but then this g of 0 down below is no longer is going to give me two different possible outputs. So it's
Oh, okay.
going to end up being a function for me.
Got it. And then that would not be a function. Okay.
Yeah. Yeah.
I think I
So whatever your input is, we need that consistent output.
see. Cool. I
Yeah.
think I get it.
All right.
All right. The next one asks, which x values have points on the graph? I guess using the new vocab, that's asking what the domain of G is.
Domain. This is one of those key words. So the way I always think about it is, if I were to make a table of everything, if I were to think about this in terms of my x, y, what are my x and y values? What would be the greatest x value? What would be the least x value? And does everything in between work as well? And that's kind of what your domain is. And so I thought about it in terms of the graph of, the graph starts over here at -2 in terms of my x value, and it goes all the way to +4. And every point in between that, I can get a y value that goes along with it. So if I go up from my graph up here, I get an output. If I go from here, I get an output. So any of these points that I choose between -2 and +4, I'm going to end up getting some output on my graph or in my function.
I see. And so the graph doesn't go past those points. And so that's just not part of the domain.
Not part of the domain. The other thing I wanted to be kind of clear about too is that it also includes those values. So I said that it goes between any number. What did I say here? I said x can be any number between and including, and I wanted to kind of emphasize that including,
Mhm.
because in our graph here, -2 works and 4 works. So it's not that it's just between -2 and 4, but it's also including -2 and 4.
How could you show that it doesn't include? Like, what if I drew a graph that was that or that the domain was only the numbers between those 2 points, but not actually 2 and 4 or
Yeah.
-2?
So we've got that these little circles at the end. These are all filled in here at the ends of my graphs. So that says that -2 is included. That says that 4 is included.
Mhm.
But if we were to make those instead of a closed circle, if we were to leave them open, that means that it's everything up till 4, up to 4, or everything after -2, if we were to leave those open. So those closed circles
Oh,
tell us a lot about our domain and range.
I think this we talked about this with number lines and inequalities.
Yeah, absolutely. Yeah, when you were
Did you
graphing
guys
the
talk about
original
that in
number
your grade
lines.
or middle school?
Yeah, oh yeah. Here's your 0. Let's say x is greater than 3. 1, 2, there's my 3. So we would put an open circle. We wouldn't fill it in because 3 doesn't work, but everything to that right of 3 would work. So we leave that open to show everything up till that point.
Sick nasty. All right.
Getting it?
Okay, then I think you kind of answered. Oh wait, sorry. I skipped the question. Then what are the possible outputs for G? So then, wait, let me try this one. I think if you said that the inputs are the X's,
Yep.
and you said it goes from like -2 to 4,
Mm-hmm.
then I would think like the output, like it kind of starts off at that -2 and 4 point
Mm-hmm.
or points and ends there. And so the range could be from like -1, because that's the bottom, the lowest
Yeah.
one.
So that would be your lowest point in your Y.
Yeah. And I'm not sure actually, because like the graph, if I, kind of trace the graph from one end to the other end,
Yep.
it ends at -1, or sorry, +1.
Yep.
Yeah, -2. But then it goes up above that to, I guess that'd be 3.
Yeah, we get all the way up there to 3. So anywhere in between those points of that 3 to -1, we can get any Y value. I can go for my Y and go out and hit any part of my line. So any of those values between -1 and 3, I would say, would be part of your range or your
Okay.
possible outputs.
So range should be everything it's from -1 to 3, including.
And including my favorite word, including. So that way we make sure that because of those closed dots that we are using those.
Sweet.
All right.
Okay. And then so Ricky says that his range, he said the range was -1, 0, 1, 2, 3. And and is he correct or not? But it sounds like that's the same thing that we just said.
Yeah, so Ricky, you're right, and you can improve on that answer to make it even more correct. So, like we said, -1, 2, 3, 4, all those values. Is that am I thinking of the right one? Or from -1 to 3, all those values work, but we also have more values in between those that also work. So, for instance, if I were to do
Oh,
negative half, I would still be able to have an input that gave me that negative half. Or if I were to use 1/2, I would also be able to get those.
okay. I guess I'm just still in the mode, like if I say this from every number from 1 to 10 is just 1, 2, 3, 4, 5, 6, etc.
Yeah. Oh man, there's an infinite amount of numbers between 1 and 10. We got to make sure that we cover those.
My goodness.
Yeah.
Okay. um, do we need to do E? Talk about other.
Yeah, I did a little bit about E because, like you were saying, other functions. So we've looked so far in this lesson, in this year, we've looked at square roots, we've looked at absolute values, we've looked at quadratics, and all of those have limited ranges. And I think it's easiest to see limited ranges when you're looking at graphs, and that's what this long writing's about. Is that when you look at your graph, you can see that it cuts off, that it doesn't go below a certain point. In the case of the square root of x here, that it doesn't go down below. So in this case, we know our range is when y is anything greater than or equal to 0. We've looked at quadratics. We can just sketch one real quick.
Oh, those are the ones with the U shape, right?
Yeah, those
What?
are U-shaped. So we can see that if I were to have any kind of axis here, that this would be my highest point. My y value is never going to be greater than that. In other words, my range is never going to be above that point. My y values will only work for below that value. So we've looked at a couple of these that have some limited ranges, and these aren't the only ones either. There's at least one more that we've looked at that has a limited range. But like I said, the graphs I always feel like are the easiest ways to view this.
Cool. Okay, and then
All
it
right.
gives us some examples to find the domain and range of.
Yeah, so we've got our 6 different graphs here, and I always kind of like these just because it makes you think a little bit more about the function aspect, and just this is good practice for domain and range. But I looked at 3 of them in particular.
Mhm.
So I looked at A, I looked at B, and I looked at E.
Okay.
And for A, for me, that domain and range part, when you're looking at that domain and range, your domain is what is the smallest x value, what is that greatest x value. So your domain is anywhere between -4 -3 and +3. And that range works that same way, though. What is the smallest value? What is the greatest value? And so your domain and range in this case, it's one of the unique ones. And that's why I kind of like circles is they have your, they can have the same domain and range.
Interesting.
But
This one would
go ahead, take it away.
Function, right?
Why not?
Because let's just say like you plug in x equals 0,
Okay.
then half the time you'll get a y value of 4 or 3.
Yeah.
And then, but you could also get a soda that spits out -3.
Yeah.
Down there. And so you plug in 0, you don't know what you're going to get. So it should not be a function. It's not consistent.
Not consistent, not a function. I love it. For part B, this is our linear. This is what you spent 8th grade looking at. This is your straight lines. And in these cases, these are functions for us. Kind of going a little out of order here, but it has to do with that. Just like you were saying, if I plug in 0, I'm always only getting back -2. If I plug in +2, I'm always only getting back 0. Those are the only possible outputs when I'm picking these inputs. And the real reason why I like these ones, though, is the domain and range, I think, are the most fun because these lines go on forever. We talked about what a closed circle, if we look at part C, that's got a closed circle. We know what that means. Well, part B has arrows, and we know what that means, too. That means it's going to go on forever and ever and ever and ever on to an eternity or for an eternity. And so we know that those functions then are going to have a range and domain that goes from infinity, -infinity, to positive infinity. And so it's kind of weird to think about, right? There's a negative infinity, positive infinity, and anything in between that.
Oh, is that why Mr. Chan tells me to draw arrows on my lines?
Oh, it's so important. So important. The endpoints are crucial.
So with C then, because it looks almost the same thing as B, it still is a function because it's still a straight line. And no x has 2 y's, but its domain is what, -2 to 4? Including the -2 and 4, and then the range would be from -4 to 2.
Exactly, yeah. So a little flip-flop. Well, there's some similarities.
Cool.
But yeah, they do not have to be. So the last one that we wanted to peek at was part E here. And part E, I chose that one just because it was another one of those that was kind of unique and a little fun. It's not a normal function that that we normally look at. I don't know. Let's drop that. There we go. Oh, that was almost disaster.
Technical difficulties.
Yeah. So E is another one of those that I think is kind of fun just because it's got a kind of unique domain and range, but it also has that unique aspect about function. And in this case, it's not that function. If we look at what happens when x is 3, well, if x is 3, that means y can be 0, y could be down here at -2, or y could be up here at +2.
Doesn't it have 3?
Yeah, so when x is 3, you could get 3 different y values of 2, 0, or -2. And so right there we know, well, not a function, not going to work for us.
But we can still say what its domain and range are.
Yeah. Well, how would you describe that domain and range?
Let's see, the domain, the farthest left is at, what is that, 2, thank you.
Yep.
And the farthest right is at 4, I think.
Yeah, I would say that looks pretty good for your domain.
Does it matter if the range, the domain, the end of the domain gets hit multiple times? It doesn't mean anything, right? Like it hits 4 2 times and it goes like this squiggly.
That's a good point. It doesn't. It hits 4 twice here. Awesome. That's we're just looking for those possible values that x can be, and x can be 4. That's all we're looking for.
Cool.
Awesome.
Yeah. So the domain would be from 2 to 4, including 2 and 4, and then the range would be the lowest of -3 to 2.
-3 to 2, yeah.
Including those 2 points.
Yeah, absolutely. And I would say that's exactly what I had written before. So the domain is from and including, you know, I gotta add those favorite words here, from 2 to 4. My range from -3 to
Oh,
2.
that's what that is? That's and?
And, oh yeah, you don't know that and symbol?
Oh, I didn't know yours.
Oh yeah, that's a great one. Actually, I've always curious, is it a 3 or is it like an E? Am I going the wrong direction? Should it
I
be
don't know.
should it be like this? I don't know. And then my last part about that not being that function, because like we said, there's multiple outputs for those values, and we kind of highlighted this aspect earlier. All right. Well, right on. Well, hopefully this was a big help. If you've got any other questions, just reach out to us and we'll take it away from there. Mr. Cheng, thank you very much.
Thank you, Mr. Knight.